Hi everybody, so this is part 2 of our function features notes. We're going to talk about more to do with functions, particularly from graphs, but also from tables and equations in these notes. So first is increasing and decreasing intervals. So when you're given a graph and it says what intervals does the graph increase and on what intervals does the graph decrease, you're going to use these notes. So notice the answers are going to be written as a domain, similar to the notes we did yesterday. So this is where we are only concerned about the x values. Only. We don't care about the y. So we can scratch that out just like we did when we were practicing domain and range today. So the increasing intervals is where the graph is going up when reading it from left to right. So I'm going to highlight those areas right now. So if I start at this arrow, it's increasing there, and then it goes down a little bit, and then it increases again right here, and then it goes down, and then it increases here, and then it's actually still increasing here. It's just increasing slower on that end. This is usually written in, not set notation, excuse me, interval notation. Sometimes we use inequality, but let's leave that off. Okay, so decreasing is going to be where the graph goes down when reading from left to right. So that's going to be this space right here and this space right here. Increasing was this one. And decreasing, sorry, color coding fanatic here, was this one. Also usually written in interval notation with the parentheses or brackets, depending on if it's open or closed circle. Faster or slower? Oh, I meant to do an example, sorry. Increasing is the yellow. So we're going to write an interval of increasing from negative infinity until about negative 6.5. So negative infinity to negative 6.5. That negative 6.5 is included and negative infinity is not included. The next area where it's increasing, we'll say A right here, so this is A. B would be this one, and that is from about negative 3 to 0. Negative 3, comma 0. Now the 0 is not included, so we're going to put a parentheses on there, and the negative 3 is included, so we'll put a bracket. And then we have another area of increase that is from right here at 2, and it continues to infinity. So infinity is not included, and the 2 is not included because it's an open circle. So decreasing, we have the A. Let's do A, B, C. Sorry, go back here. This would be C. And then we've got a D here and an E here. So D is going to be decreasing from that negative 6.5 until we get to the negative 3. Both of those included. And my E, if I can fit it in here, is decreasing from 0 until we get to 2. And that 2 is not included because it is an open circle. And the 0 here is closed. So bracket. Okay, faster or slower. This is also going to be written as domain. So when I mentioned in class that we write most things as a domain, that's what I was talking about. Range is only used for range. Domain ideas, the left to right, is going to be used for any time that you see the word interval. So faster intervals are steeper on a graph. And slower intervals are less steep on a graph. To compare rates with exponential or curved graphs, find the slope using the endpoints, so still rise over run, even though it's not a straight line. So steeper over on this graph, let's just go and find the slope for each piece. So if we find the slope for this piece right here, let's use this dot right, cancel, right here, and this dot right here. We have to go up and over, and that was up, let's see, 5 and over 5. So we have a 5 over 5, which is a 1 for my slope. This next piece is going to go down and over, and it's going 1, 2, 3, 4, 5, 6, down and over 1. So negative 6 over 1. So this is going to be a 6 rate of change. Notice I didn't put a negative in there because we don't care about the direction it's going when we're talking about faster or slower. We only care about the number itself. And then here, last piece, we have an up 1, 2, 3 over 3. So this is 3 over 3, which is also 1. So my steeper is going to be the part B on the graph, let's call it. And my less steep is going to be A and C. They tied for being the least steep. All right, so now we're going to talk about vocabulary words. This vocabulary word here, continuous, we've already talked about that with stories. It's something that is happening all the time. So even in between day 1 and day 2, for example, something is still happening for those times in between. So what that looks like on a graph is, it is a graph that can be made without picking up your pencil. So here's an example. I start down here and I go up, over, down, and didn't have to pick up my pencil at all. So this would be a continuous graph. A discrete graph is one where contains only points and no lines. So it's something that happens and then time goes by and then it happens again. So there are pauses or gaps where nothing is happening. So here we can't, and the other way you can say this is must, oh, I can't spell today, sorry guys, must pick pencil up in order to make it. So make a dot, pick it up, make a dot, pick it up, make a dot, pick it up, make a dot, pick it up. Now, discontinuous is kind of a combination of those two things. So it's a graph where you must pick up your pencil. It contains continuous and sometimes discrete parts. So start over here, draw down, and then all of a sudden there's a gap. Pick it up, draw a discrete point, pick it up again, and draw down. So it's kind of a combination of the two things. All right, so is it a function? We have already talked about functions in terms of the vertical line test on a graph. So now we're going to talk about ways to tell if it is a function without a graph. So first, for every input, there is only one output. Okay, so in an XY table, we have the in and the out. So that is what this is talking about. So think of a soda machine. When you hit the Coke button, that's like the input. What's supposed to pop out? Only a Coke should pop out. If you press a Coke button, you do not want a Sprite to pop out. Only one thing should happen based on hitting a Coke button. Now, we can have multiple Coke buttons. So for every output, there can, not always, but there can be multiple inputs. So that's where you see over here that you have like two different Coke buttons. They will both give me a Coke. So I can press two different buttons but get the same result. So in order to get a Coke out, there can be multiple buttons that work. Sorry, typo there. Multiple buttons that work. That S should not be on there. Okay, so here's how it translates mathematically. So if we have evaluate the following for x equals 4, plug that in right there, and I have 2 times 4 minus 3. So this is going to be 8 minus 3, which is 5. Can there be more than one answer for y? Is there a different way to calculate that and get a different answer? The answer is no. We have to follow PEMDAS. So if Johnny did that calculation, he would get 5. If Miss Thompson did that calculation, she got 5. And if the President of the United States did that calculation, he should also get 5. So that's the example of for every one input, we get one output. So then looking at the next one, for the following function, what x values, which are the inputs that we don't know, give you an answer of 9, which is the y value. So basically we want to say 9 equals x squared. So what values, what numbers can I square to get 9? Well, we can have x equals 3, because 3 times 3 equals 9. Or we can have x equals negative 3. Negative 3 times negative 3 also equals 9. So this is like the two different Coke buttons that both gave me a Coke. So negative 3, Coke button number 1, Coke button number 2, negative 3 and positive 3 both give me a value of 9. So what does that look like in a table? Here we have the XY table, and 1 is going to 0. 3 would give me a 4. 5 would give me an 8. So far, I'm good, because if I plug in a 1, I get a 0. If I plug in a 3, I get a 4. If I plug in a 5, I get an 8. Now here's where I'm worried, because I have repeats. Usually not allowed. And in this case, it doesn't work. This is like Miss Thompson plugged in a 7 and got a 12, and President Obama plugged in a 7 and got a 16. because we got different answers, then this would not be a function. And if we were to graph this, it would not pass the vertical line test. Because of the fact that we have two x values of 7 and then a 12 and a 16, they would be stacked on top of each other. Okay, so this is called a relation, and it's basically just like an XY table. So here we have X, here we have Y. Remember, X is domain, Y is range, so that makes sense. Here, input is X, and Y is the output. So if we look right here, we have putting in a 2 gives me a 4. Putting in a -8 gives me a 0, but putting in a 1 gave me a 5 and a 3. So this part right here makes it not a function. This is where the Coke button gave me a Coke button gave me a Coke the first time, and it gave me a Sprite the second time. So malfunctioning Coke button. Okay, so then looking at the next one, 1 gave me a 2, that looks good. 2 gave me a 4, and 3 gave me a 4, and then 4 gave me a 5. This one, students tend to say, nope, not a function, but this one is a function because this is like 2 Coke buttons give Coke. So here's the Coke. And this is button 2 and button 3 that both gave me Coke. Okay, now you might be given a set of XY coordinates. So just these are different representations that we're seeing here. So these are all XY points. It's easiest if you put it into a table. So let's go ahead and do that. So we have X and Y, and we have 4, 3, -7, 2, 5, 1, 4, 3, and -3, 1. So I'm just looking really for any repeats. So we have here, get a color here. So 4 is here and also here. -7 only exists once, so it's good. 5 only exists once, so it's good. -3 only exists once, so it's good. So looking at this 4, 3, and this 4, 3, those are actually still good because they're identical. So now if I kind of look at the Y values, but remember Y repeats are allowed. So here I have a Y repeating and a 1. This is different than this. Is that allowed? Yes. This is 2 buttons, same soda. Example. So this is button number -3 and button number 5 both gave me a Coke. So because this is good, and we have good here and good here, then the answer is yes, it's a function. All right, so evaluating functions, I think we're in this home stretch here. So using a graph, if we want to find f of some number, I'm not going to fill that in. It's not a blank for you to fill in. It's f of any number, okay? So any number, you can write below it if you want to, or just leave it as a blank. So my steps for that is we need to go to that value on the x-axis because this is an x value. And we're going to go up or down to the line, then left or right to the y values that go with it. So that's this example right here, f of 5. So I'm going to go to 5 on the x-axis, and I'm going to go up and then over. And I have a y value of 7, so the answer would be 7. Now, if I want to find f of x equals some number, so any number can be in here. So f of x equals some number means we're going to go to that value on the y-axis because this is basically a y, where over here this is an x value. So that was a y value. Okay, let's skip that because that's not working. So that's a y value. Okay, so we go to that value on the y-axis. Then we're going to go left or right to the line, then up or down to the x values that go with it. So if we have f of x equals 3, and I should have used a different color, we'll shift gears here to green. So f of x equals 3, go to the 3 on here. Okay, so f of x equals 3 is that 3 value on the y-axis. Sorry about the interruption just now. I have an impatient child. Okay, so we're going to go over until we get to the line, and then we're going to go down. So that's going to give me a 1. However, I also need to go this direction and down to the negative 5. So this one happens to have 2 answers, a 1 and a negative 5. So 1 comma negative 5. Or you can write that 1 and negative 5. Okay, so finding f of something, we are going, if we have the explicit function, we plug that in place of the x, and then we evaluate using PEMDAS. You guys kind of know this one already. So we are going to find f of negative 6, which means we're going to plug in a negative 6 right there. So 1/2 negative 6 minus 4. Multiply first before subtraction. So that's negative 3 minus 4, which is negative 7. So I have negative 7 as an answer. Okay, last little bit here is finding f of x equals some number. That's where we're going to plug this in place of the y, or f of x, and solve the equation for x. Notice it says x equals, that's what we don't know. So I'm going to take the 5 and plug it in here. Now I'm kind of running out of space, so I'm going to do this over here and do 5 equals 1/2 x minus 4. First step is to bring the 4 over here. And I get 9 equals 1/2 x. And then if I multiply by 2, that cancels. Multiply by 2, and I get x equals 18. So that will be an 18 as my answer. All right, see you guys tomorrow.